Welcome to the premiere episode of the TAPS podcast on May 29th, 2019. I'm Aidan, and I'm here with Brian. For today's show, we are talking about Team 179, Children of the Swamp, and we have James, a 179 mentor. Team 179 was founded in 1998, had a pretty dull history running up through around 2005 when the team started to win various regionals and place in divisions at Worlds. Moving through up into around 2012, where our history during this episode is really going to start, when 179 went through a breakout multiple years of winning Excellence in Engineering over and over and over again, which is a major landmark award for the team throughout its history from 2012 to 2016, winning the award around 8 times along with Industrial Design, all of which show the engineering prowess of 179, at least at the regional level. But moving on past 2016, you see 179 developing into a Worlds level and an Einsteins level team that can show off their robot on the Einstein stage like last year in 2019, which really proves their engineering prowess and their ability as a robotics team.
So, James, tell us a bit about yourself and your role on the team.
Alright, I've been involved with FRC since 2006. I started out as a student and moved on to mentoring. I've done pretty much everything there is to do on a team from both a student and mentoring standpoint. On 179 now, I am the strategy and scouting mentor. That basically means at the start of the season, I handle game breakdown, where we're heading with the robot design and how we think the game will be played. During build season, I deal with any sort of rule changes or any interesting things that other teams may post or figure out so we know where other teams are heading. At actual competitions, I handle all of the scouting data, and then match to match, I help with the strategy with the drive coach.
So James, why do you think that 179 won the Excellence in Engineering Award so frequently throughout the years from 2012 to 2016?
So to really look at why we got the award so often, you really have to actually go back a whole year, back to 2011. In 2011, 179 built an extraordinarily simple robot. It was basically just an A-frame with a drivetrain and one moving shoulder joint with a PVC pipe to score tubes. There wasn't a whole lot to it, and upon going to Worlds, we got destroyed and decimated and didn't get selected for elims. So heading into 2012, we had this idea of, what is the robot that not only could win a regional, because we know we can win a regional with a PVC pipe stick arm, but what would actually get us selected and to do well at Worlds? And that whole principle has stuck with our team since that year.
So that's actually really interesting. It's one of the things that Karthik preaches pretty frequently, is that you have to think from each level of design as, what do I need to do to win a local event or win a regional or win divisions in Worlds. You have to think at each level of competition, what are you actually doing? So I think it's interesting that a team that had so much success with their engineering utilized a similar strategy.
So, you'd mentioned that you guys went to Worlds back in 2011. But here, historically, you guys didn't make it back to World Championships until 2014. What happened in 2012 and 2013 that you guys had missed inside of that engineering process?
The issue was we basically started running before we could walk. We made the decision that we were going to be a world caliber, world competing team, but forgetting that in the regional model, you still have to get to Worlds and compete there. So your robot still needs to be good enough to win regionals. In 2012, there was a fatal flaw in the design that basically in a team version of a game piece, we could manipulate it very well and interact with it exactly how we thought. But upon actually reading what the object was made out of and then experiencing it on a real field, it just was never going to work the way we intended. But in 2013, we learned from that, and then we built a field-specific version of a game piece to interact with. Interacted incredibly well, but at that point, the robot didn't let us down, our scouting and humans let us down, and we selected the wrong teams to get us there.
Interestingly enough, that's something that happened pretty frequently, I think, this year in 2019, especially with the practice field that we were given on our teams or throughout all of the competitions where the practice field wasn't entirely accurate in the pickup zone for hatch panels, and some of the practice fields, in fact most, did not contain the brushes. So teams that built their own fields or utilized a practice field were not really experiencing what it would be like to pick up the hatch panels from the actual loading station, which became a difficulty. Would you say that it's important for teams to put an extra focus on how the real field will be built rather than how the team sample objects will be built?
I think it's incredibly important for teams to not only think about what first is telling you, like the measurement, oh, it's this high, oh, it's that wide, but also what it's made out of and how they all interact with each other. Teams probably learned this year, it is very, very easy to do a third level climb on wood where you have a bunch of traction on your wheels and a lot of traction to be able to actually get the climb up, but all of a sudden when you switch to HDPE and it's a lot more slippery, you don't have that same traction, and I think that's why we had a lot of, press F to pay respect moments throughout the season of people just falling over because they don't have the right friction.
That's definitely something that was very noticeable throughout all these years. Specifically in 2012, a lot of people didn't realize how slippery those teeter-totters were going to be. That's why most Mecanum robots failed at climbing up those teeter-totters.
So James, during 2014, did you specifically focus on interaction with the field in your robot design to ensure that you were able to overcome the same challenges that you experienced in 2012?
In 2014, the game didn't really lend itself to field-to-field interaction. Because the field was so open, it was really just carpet and goals, our big thing was touch it, own it with the ball. The moment that we would touch that ball, we wanted it in our robot, in our possession, we wanted to have it throughout the entire match until we wanted it gone.
Did the 2014 season help boost 179 towards success in the future?
So the 2014 season was a catalyst season for 179. That season we made twins with Team 1251, the Tech Tigers, and they had a lot more machining capability than we did. So we got to actually interact with a team that was a heavy CAD, machine part and get stuff ready type of team, as opposed to us where we were a lot more making stuff by hand and limited machining capabilities. By teaming up with somebody with a completely separate design philosophy from us, we were able to pick out the stuff from them that we wanted to adapt in future seasons, but also see what stuff they were specifically looking at with us to not get rid of. It's not so much the design of 2014 Aerial Assist as a game, it's more so the new blood being injected into the team by making twins with somebody else and seeing opposing design philosophies and working to compromise.
So why then did you not make it to Worlds in 2015? And following up on that, what changed moving into 2016 that boosted you all the way up to being the 4th Alliance captain in your division?
I would really say that 2015 is another one of those years where we learned something very important and we learned something new, and then we didn't really know how to apply the knowledge just yet. 2015 is what I would call a beautiful science fair FRC robot. There are tons of different robots in FRC. There are those who try to make something beautiful that wins competitions, and then there are some who feel that FRC is just an extended science fair, where the competition is your presentation to judges as they come around. Our 2015 robot was beautiful and it moved so nicely, but when we actually needed it to go out onto a field and interact with other robots and the game pieces, we didn't really know how to apply all this new engineering knowledge to really limit ourselves, which led to an overcomplicated robot that had an unfortunate tendency to tip over. So taking what we learned in 2015, heading into 2016, we knew that we still wanted to go what would be a complicated engineered robot, but we now knew what our limitations were in terms of machining time and capabilities, and how we could better apply them to make a robot that not only looked good and looked very impressive when just sitting in the pit, but could actually perform on the field. In 2016, we actually went to 3 regionals and we got the Excellence in Engineering Award at all 3. My personal favorite of them is the Rocket City Regional, where there was beautiful robots from 118, 16, and 624 there, and we got the award nod over all three of those teams. The biggest takeaway from that season for us, though, was actually a bit of a detriment. Despite a regional win and a finalist appearance, we now had a robot that could compete when it worked. We now needed to head from 16 into 17 and figure out how to make a robot that worked every match, not just worked very well in the matches where it decided to work.
So what you're saying is that during 16 you had a little bit of a consistency issue, and how in 17 did you kind of correct for that consistency? And even more specifically, what consistency issues did you see in 2016 that other teams should look out for?
So one of the biggest things that we learned in 16 was maintenance and checklist. That was the first thing that we knew we were doing heading into 17, is we had a list ready in the pit after every match, check every nut, every bolt, make sure all the wheels were spinning, how's our wear and tear, because in 16, because that was such a brutal game, if you didn't check everything, that field was going to tell you what you didn't have secure and locked down. Before we even knew the 17 game, we knew we were going to look at that, and that's something that I feel every team should have. Not just like, the big things. Oh, make sure the wires are connected, but it's little things that you don't think about, Put the robot up, let the wheel spin, look at the chain. Does the chain look like it needs to be tensioned? Is something making a weird sound? It's just all of those things. You should actually run almost an entire match worth of runtime on your robot, if you have the time to, in the pit, to make sure that every little thing is still working. One of the best examples of us having intermittent issues with that robot would be the first finals match of South Florida that did not end in a field fault. Coming out of auto, you can actually see our robot has its intake completely stuck up. We actually have to use one of the parts of the field to help get it down. We are then able to use our intake to intake a game piece, but at about the 34-second mark, you could see the robot go over and completely turn its turret 180 degrees, which it is not supposed to be able to do. So we completely break our turret at that moment. We then attempt to score in a low goal, which involves us lifting up our intake, which we already knew was broken, and it just gets stuck up and out. In that moment, there is 4 different subsystems that are all completely broken in that match. Our lift arm, our intake, our actual shooting mechanism, and our turreting mechanism are all completely destroyed, and it was all something that could have been prevented in the pit with proper checking of wires and just proper running the robot before we headed into a finals match.
Even with all of those issues in 2016, it still looks like that season was the start of that bull run all the way up until Einsteins here in 2019. Were there any design process changes more specifically, from 2016 to 2018 that led to you guys being the second seed alliance captain of Roebling in 2018 at Worlds?
I wouldn't say design process, I would say it's a continued evolution of our design philosophy as we kept going. In 2016, we did have all of those mechanical issues that we attempted to correct in 2017. The issue the 2017 robot had was it was super consistent, it never broke in matches, it would do everything we wanted it to do except for what 90% of the robot was dedicated to, which was shooting fuel. We fell into the same mishap that year that a lot of teams did, which was thinking that we needed the shooter and we needed the fuel. So 2017 and 2016 together taught us we need a consistent, reliable robot, but we need to actually understand before we head out to actually show off the robot and compete with it, everything needs to be done, everything needs to be 100%. It being almost good enough in the shop isn't good enough.
So, as the strategy or the head strategy mentor for 179, what did you personally do between 2017 and 2018 to focus on robot design and ensure that your robot design matches an effective strategy?
It was a lot more of we actually knew what the effective strategies were. If you look at the 15, 16, 17 run, the robot is designed to do everything that the Einstein winners do. It's just that we needed to actually get to the point where the design actually works. We knew what we had to do. We just now needed to do it. And 2018 was that point where the 3 to 4 years of learning all finally came together. We knew exactly how much time we needed to dedicate to each subsystem. If it wasn't going to work, we knew exactly how we were going to course correct each subsystem, and we also knew that the robot couldn't be a static invention. If you look at the 2018 robot and you look at its wings, it has a different set of wings in Orlando, a different set of wings in South Florida, a different one on Roebling, and then another one for Wivrox. One of our biggest takeaways while we went through that season, which would lead us into 2019, was we actually had a list of all the things that we wanted to do, the wings, the climb, the scoring from either side, and we realized all of this stuff we wanted to do actually overcomplicated the robot. We started to go down and we said we could have survived without this, we could have survived without that. We were building 120-pound robots, and we started to think, well, why are we? Like, did the claw need to flip through? No, so why did we do it? And that design philosophy led to a simpler 2019 robot, but a much more effective one.
I'm sure at the beginning of each year you go and brainstorm and strategize as to how you want to build your robot and what you want to do to play the game most effectively. But as you mentioned before, you've kind of incorporated iterative design into your post-build season process. So what do you do after the build season to really focus on your iterative design between competitions and out of bag before each regional?
Well, as a regional team, we don't really have an out-of-bag time. We only have that 30-pound withholding allowance that allows us to actually use on the robot. Heading into 2020, that doesn't really matter because we aren't going to have a bag, so everybody can do basically what they want. But in between our competitions, we would look at, okay, what didn't work? How can it work? How can it be better? Can we do it in 30 pounds? If we can't do it in 30 pounds, how quickly can we make it and do it at the competition where there is no withholding allowance? The 2017 robot actually went through, by the end of the competition, I would say 3 or 4 different gear acquisition mechanisms, since we realized very quickly that our shooter was not going to work, so we needed to be the best gear robot we could, and we did fairly well with that. The 2018 robot had different wings, different claw, a different gearbox for the elevator. It was all about identifying what could we do better and what were all these other teams that we were now looking at as competition down the line could do. What was 254 doing? What was 118 doing? What's 125 doing? What is the best robot in the world at that moment doing? And what can we do to compete with that?
So it looks like all the trials and tribulations of 2016 to 2018 really laid the groundwork for 179 having this amazing 2019 season.
The previous 3 years were super impactful on our 2019 season, especially because those were the 3 years that our seniors heading into were able to actually draw upon for this robot.
All right, so let's get to the point at hand. Run us through what 179's 2019 season was like.
Coming out of kickoff and seeing the game, we broke into small sub-teams while we all had a quick lunch and just started thinking up different ideas and how we were going to go about it. And one of the biggest things, because of 2018 where we had the wings and did the triple climb, we thought heading into our initial design that we were going to be a triple or a double level 3 climber. But as we started breaking down the game, we realized that the amount of space and effort you really have to dedicate to that isn't really worth it in the long run. And you kind of did actually wind up seeing that come to fruition later on in the season, where even the best team in the world at doing it still couldn't beat just 2 robots who could get up there by themselves. But going back to the start of the season, the breakdown basically goes with a meeting where we're breaking down what's the game, how is it played, how do we score, and then what are the RPs, as have become very prevalent in the last 3 to 4 years of gameplay. How do you get them? How do we need them? Which one do we think is easier? which one do we need somebody to help us with, which one do we not need somebody to help us with. And our decision coming out was we wanted a light, fast robot that could solo a rocket and get to level 3. And the plan was we weren't taking anybody with us. We were just going to get up there as quickly as possible and take up as small a space as possible, because we knew even back then that eventually you're going to need to fit somebody up there with you.
So James, how did all of that come together into your actual robot design over the build season?
So all the breakdown basically led to us thinking about, in order to make our light, fast, and efficient robot, basically we started looking at, ironically enough, things that worked on our previous few years. We needed a quick game piece acquisition, especially for the cargo, which we basically just copied a version combining our 2016 intake with 971's 2016 intake, which we thought was one of the best ones out there. Then it was, how do we actually get the game pieces up and to the top of the rocket, because that's going to be the thing that's going to be hard to do and who we're going to most likely have the least amount of help with. And we just looked at the best elevators out there. Our elevator in 2018 we were really confident in, but we knew it wasn't the right elevator for this one. So we looked at all the other 2018 elevators, people who did elevators in 15, people who did elevators in 11, like 254. And we combined them to make a simple elevator that we thought would be able to handle the game pretty well. The longest discussion was really about our drivetrain and how we were going to get to the third level of the hab. There was a lot of back and forth about, do we need 2-speed? Do we need 1-speed? Okay, are we going to go with Sims? No, we're not going to do Sims. We were going to do 775 drivetrain, but we did a breakdown and we actually found that the Neos at the lower end had a better torque rating than the 775. So if we were going to go with a single speed, the Neos had a quicker acceleration and a better torque at the low end than the 775 did, at least in our testing. And since the field was so small, you're really only going to be running from the feeder station to the rocket as your longest cycle. Acceleration was more important than top speed, which is where the 775s beat the Neos. But the level 3 was a lot of discussion about, do we want to do a claw, use the claw to go down? No, because we want the claw to be light, and if we were going to use the claw as a structural element, we would need to make it heavier and bigger, which would mean that we would need more power in our elevator, and we would need thicker metal in the entire claw to prevent anything from bending or breaking. So we knew we couldn't rely on our claw. So we came up with the inset level 3 climber, which if you look at pictures of our robot, you can actually see there's a chain run going all the way from the front wheel up and into these small towers that are right next to our elevator. Those are what actually descend down, and they're at constant tension with the drivetrain. So even when they're up, those little wheels are spinning and are a part of our drivetrain. After the lovingly called giraffe legs deploy out, we started to realize the issues that happen when you switch from a nice, big, rectangular drive base to 3 wheels that only 2 are powered and the back ones are on omnis to actually move. So we realized when we were trying to line up that it was never perfect, because with any system, especially when you use the double joystick tank style, not arcade style, you're never 100% driving both sides at the same rate. So after a lot of testing and a lot of falling over with the design, we realized that once the legs went down, we needed to switch to a one joystick style that drove both halves of our drivetrain so we could get up there straight, and then once the legs came back up, it would switch back over to the double joystick so he could do fine-tuned movements once he was up.
Did any of that control system play into winning innovation and control at the South Florida Regional this year?
So I would say that the controls did take a part of it, but I think our biggest thing with the innovation and control is this robot was by far our least human interacted robot we had ever made. The robot auto-acquired its target for both getting hatch panels from the human player and getting cargo from the human player and scoring it in either the cargo ship or the rocket ship. Our driver really only drove it if something had gone wrong or to get from the station to the ship or to the rocket or cargo ship, and then vice versa. So for the most part, all the scoring was done by the robot itself. Our human just put it where it was supposed to and then said which level he wanted to go to.
What was it that 179 used for vision this year?
We actually used the limelight. We started off with one limelight that was at the base of our robot looking up, but we realized that when we were actually scoring low on the rocket or on the cargo ship in general, our claw would actually block it. So by the end of the season, we had 2 limelights, one at the bottom of our robot and one up above the claw, so that way no matter what position we were at, we could always see our target.
So would you say that the limelight is a good option for rookie teams looking to get into their vision, or looking to get into vision?
I would say the limelight's a great idea for any team looking to get into vision, rookie or veteran otherwise. We had a pretty good vision system in 2016, all done with the old USB cameras and the LED rings, and we found that we had way better results with the limelight, and it was so much easier to integrate.
Okay, so moving on from build season, let's go into the competition season. How did that go? Explain it to us.
So our competition season actually starts slightly earlier than some other teams do. We host a scrimmage during the end of build season that allows for other teams to come out, and because our facility does have so much space in a field, we do get a lot of different teams who come out and practice with us and interact with us. And from the teams that came out and who we were interacting with, we thought we had a very good shot in Orlando, especially even later on when we saw Palmetto, where a lot of the other good teams who would be in Orlando had already competed. We saw in our shop that we were doing as well, if not better than them. When we actually got to Orlando in our practice day, we went out onto the field and we filled rockets in quite a few of our practice matches. That probably was not the best strategy choice for us to show off and be so affluent, because we went through the entirety of the Orlando Regional with the most brutal defense I have ever seen. We had robots wind up inside of us. We had whole parts of our robot get bent. We had somebody who actually drove up into our pneumatics panel and jumped our PSI to double what the safe limit was by just spinning on top of it. So it was brutal. We wound up only filling, I think, only one rocket, and it was in our very first match. And then after that, we were never left alone again to do it. So at the end of Orlando, we did rank 3rd. We wound up denying the first seed alliance and decided to make our own alliance, because we knew that if the second seed was able to pick who the first seed wound up picking, that we would not beat that combo together. And that wound up biting us, because we didn't even make it to the finals to attempt that. We lost in the semis to the eventual winner. So the decision was made in between Orlando and South Florida that the robot, when left alone and when able to actually get some breathing room, did exactly what we wanted. There was nothing that we felt we needed to change in between Orlando and South Florida besides just strengthening a few parts, moving a couple things around to put them into safer locations. So our time between Orlando and South Florida was spent getting 2 other robots back up and running and having our driver just practice with experienced mentors on our team driving those other robots, playing defense, playing counter defense, saying, okay, what do you do in this situation? Setting up picks, just getting our driver used to the hard defense that he was seeing in Orlando and how he could solve it.
So I know a lot of teams end up building, a second practice robot, but even without a practice robot, using old robots, you manage to get that same effect of practice and getting your driver practice in. How did it help you leading into South Florida?
So it was a tremendous help, because since we are a regional team, we don't get on bag time. So we had a spare Andy Mark Kitbot chassis from a year that we didn't opt out of it. So that's what we did at one of our weeknight meetings, was we quickly built that and used that as a counter defense robot, because we knew that we were going to see Andy Mark chassis and how to best utilize them and what they were capable of was knowledge that we found very useful, so we weren't asking teams to go beyond what their physical limitations were, and we were utilizing a resource that we had sitting around for a few years that most teams do have available to them. So heading into South Florida, all that driver practice, all that driver training, and just getting our driver used to not being left alone made South Florida and Orlando almost night and day competitions to us. We filled rockets in most of our matches under defense, sometimes with somebody helping us, quite a few times without it, and it led to us going undefeated in South Florida with almost no mechanical issues straight throughout, and then going through elims, never dropping a match, and averaging over 100 points in our elims matches with defense on us.
Wow, sounds like a great competition.
I would say that South Florida is the real final look of what our team had been striving for since 2011. That 2011 Orlando Regional was another undefeated regional for us, and then we went to Worlds and got destroyed, like I said earlier. We finally got all the parts to be together and finally had another undefeated run, but this time with a robot that we knew was going to make a splash at Worlds.
So tell us about that. How did Worlds go?
Before we even got to Worlds, we have the usual hullabaloo of our division is announced, who's in our division, the Delphi threads of who's going to wind up with who, what's going to go on, and then the dreaded, what does our schedule say? And we have mostly okay matches. We looked at it like we always had somebody we could rely on, and then we had our completely just shattering match 62 where we were up against 399, 1986, and 971, and it was just crushing to see that and never getting to interact with 971. So we knew that we needed to do whatever we could to not wind up in the same position that we did the previous year, where we were the third rank robot on the outside looking in to the number 1 seed alliance that we just could not beat. So we decided we were going to change our hatch acquisition mechanism. We went from 2 metal fingers that would grab the hatches from the inside to what became known as like the California or the IFI claw with the double wheels. We decided that we never really used our ground intake for hatches, so we took that off to save weight. We even designed, but never really implemented, a pneumatic climber with a pneumatic plate on it, so that way we could do a 2 or 3 level 3 HAB climb if we needed it. So we came in ready to fight and ready to not be left off that alliance heading to Einstein, and it was a rough 2 days of qualifications. We dropped a match way earlier than we planned to in qualification match 41, and we spent that whole competition looking at the alliances, figuring out what was going on, and it literally came down to the second to last match of qualifications that finally ironed out who your top 8 were going to be. And then it became a guessing game of who 971 was going to pick. Was it going to be us? Was it going to be Appreciate 1986? Were they going to go with 4587, who had made a great run and was going to be number 1, if not for an unfortunate final quals match? So, something that some teams may not realize is that after the qualification matches are done at Worlds, since you do have that night off, there's a lot of schmoozing and hobnobbing that goes on that night. So we got back from our last match and we went to go talk to 971, just see where their brain's at, what's going on, give them contact info, and we couldn't find them. So we went looking around and we found them on the practice field with the probably 6 or 7 other teams that would be looking to wind up with them, just trying out, okay, can we both fit on level 2? How quickly can it be done? Can you push us? Can you do that? Can you do that? And so it was very interesting just to see this line of people basically getting presented like at a cattle show to be selected.
So what then made 971 pick you guys?
We kind of knew heading into Galileo that it was really going to be a race of who was going to wind up with 971. Whether 971 was one or not, we knew that they were going to be on the top of everyone's list. And if somebody not very desirable wound up as number 1, 971 could more than afford to say no and probably win from almost anywhere. So we were really worried about not being selected and how we were going to handle that. So after we had our turn being shown in front of 971, and we showed off our ability to push them on level 3 when they were sideways, how we fit, we actually, the first time we went to do it, we pulled up our back leg and we fell hard. And 971 didn't look very pleased, so we just went over and we just threw metal in the front of our robot until it didn't happen. And we lucked out, and we were one of the few who could do everything 971 was asking for. We had a multi-scoring auto. We would do 2 hatches on the rocket. We had the level 3 climb. We could push them, which very few could do. We fit very easily. And we had what they were calling an X factor, in that when left alone, which we were fairly confident we would be if they were eating the defense, we put up numbers equivalent to the world-class teams at the event, the 148s, the 1323s, the 254s. We were putting up just as much as they were. So if a defender came over to bother us, 971 was left to just run roughshod over the entire field. And if a defender went over to 971, like what happened, we were able to do the same. So that really is what 971's decision was. The problem was we didn't know that. So we headed back to our hotel, which was about 30 minutes outside of Houston, and we started our meeting of, if 971 picks us, who are our defense spots? Because it doesn't really matter who, if they don't, we need that list anyway. So that was our list, and we began making our list of, if 971 doesn't pick us, do we say yes to Jersey Voltage, who was the team right above us? And if we say no, who do we think are those 2 teams that are going? And can we make something that can compete? And as we were making that list, 971 got in contact with us and told us that we were selected and they wanted to have a meeting with us. They were right next to the venue, so we needed to get back into our cars and drive 30 minutes back into the city in order to have this meeting with 971 to decide where we were going with the alliance.
So we have our alliance, 971, 179, 3646, and 498. Run us through playoffs.
So we actually had a rough start to our elims run, dropping a match to the 8th seed. Despite having plenty of time to actually run through and do all the checks we needed to do, a small thing slipped through the cracks, and we have a sensor inside of our claw that actually tells when it has a ball. And once it has a ball, it basically spins a certain direction, so that way we can get the ball out. But during our process, the sensor got turned around, so it always thought it had a ball. So it would always spin the wrong direction to attempt to acquire a ball, because it was always trying to X-take it. So we could get hatches, but we couldn't score cargo. And anyone who has played this game knows that hatches are okay, but cargo's where the points are at. So we had a calming moment where we sat down, we all got our heads back on straight, realized, it's simple, we only lost that match by 6 points, and we couldn't do half the things our robot was capable of. We've got this. So we went through our checklist, again. We had a conversation with 971 where the decision was made to switch out who our third robot was, because Integra also had some mechanical issues, but 498 was ready to go. So we made the decision to go with 498. We put our chips in their basket, knowing that they could do what we wanted, and 498 rode with us straight through the rest of Galileo elims.
How did it feel after winning the Galileo division?
It really felt like almost a lifetime of decisions and sacrifices really came together finally. Finally, all the chips fell in our favor. All the hard work that we had done through not only the last 4 years, but members of our team had been around since our inaugural season way back. And to see us make not only a return trip to Einstein, but this time we were one of the powerhouses of our alliance and we had a real shot at this, was just so unspeakable. I'm tearing up just thinking about how that really felt. And for the rest of the team, it was really one of those moments of, always the bridesmaid, we always are one of those teams that like, yeah, 179 is going to do so good, but they're not Madtown, they're not Poofs, they're not Theory 6, they're not 125. And to finally say like, no, like we are here and we earned our spot to be here really is a feeling you can't describe until you experience it.
After that initial realization, what preparations were made for Einstein?
So there was a lot of emotional feeling on the team, but those of us that needed to kind of realize, we need to realize what's going on and get ready because we have, 6 matches that are going to really, 5, that are going to decide, are we going on to Minute Maid or not?
What happened through Einstein's, and what did you learn throughout those matches?
The first thing we said was we need to win 1 match. We are not going to be the team that goes 0-5 on Einstein. So we looked at everybody who was going to be there, and we knew that this was, in theory, one of our matches that we were a favorite in. Not a heavy favorite, but we could do this. So that first match, we had a discussion. We decided we were going to play our game and let them do whatever they wanted to do. And we played the same game we played in our Elam's run through Galileo, and it worked, and we got our win. So that was our first little check mark of we are not going to be the 0-5 Einstein team. The next alliance that we faced was Hopper, which was led by 2122, also with 4192 and 2046. We were very worried about this alliance because they were the one who we had really no idea what to expect. We didn't expect for them to win their division, and when they did, we kind of scrambled to figure out what to do against them. And we decided once again, play our game, do what got us to the dance, and once again, we got our win. We did notice in that match, though, that when we went to pull up our back leg, it didn't come up. And we couldn't figure out why. We were still high enough up that we got our climb, our double level 3 climb, but we were confused why the leg didn't come up. We went back to the pit, we tested it, we tried it, the leg came up, the leg came up, the leg came up. Couldn't figure it out. Now we head up to our third match, which is against 254, 3310, and they have subbed in 6986 from China. We actually were able to get kind of a interesting insight into what their plan was, because they made the decision in the previous match to come over and watch us face taters. And standing in front of our entire pit crew, they discussed their defensive strategy against us. So we knew what to expect, we knew what was going to happen, so we decided that we were going to slightly change our defensive strategy, but still keep the 2 offense, 1 defense robot idea going. We go out, very close match, is coming down to the wire. We thought we kept them away long enough to prevent a double level 3 climb. We were wrong, and then when we went up for ours, our leg didn't come up again. And we just couldn't figure out why it was doing this. And this time it didn't actually even get up. We weren't actually tilted enough to get a double level 3. We still would have lost the match, but we would have lost by a much closer margin. Had things gone differently in the 254 match and the following 2 matches, we would have made the run to Minute Maid. In our match against the eventual winners of Houston in 1323, 5026, and 973, we were going toe-to-toe with them. They were scoring a hatch, we were right there. We would get a cargo, they were right behind us. Our defenders were beating up whoever they could get in front of. And it came time to do the climb, and just like the previous 2 matches, our back leg just didn't come up. And had it come up, we would have won that match. So we now know, heading into our last match, that we are mathematically eliminated from Minute Maid. So the decision was made, we're just going to go out and show what we can do, because we know that the 1678 Alliance does go full offense. So us and 971, in theory, would be left to our own devices, and the last time that happened, we almost filled the entire field. So we were ready for it, we were hype, we were going in, we go out to do our auto, something looks a little off, and then all of a sudden, one of our motors that's inside our claw that runs both our cargo and hatch intake is just dangling and has fallen out. So we are out, we can't run a single point of offense the entire match.
So it's an unfortunate end to what really was an outstanding season, one that many teams in FRC couldn't ever have even hoped for, which says a lot. 179 went a long way from 2011 to 2019. It was a big change, and I imagine that you hope to continue on in the future. So in that same vein, how do you plan on utilizing the new rule changes that are coming in 2020 with No Bag Day to improve your engineering process and improve your robots?
One of the unfortunate things with the No Bag Day is even though it extends the build season, you never have to bag the robot, you can save money and not build a second robot if you don't want to. As of right now, our team is planning on running a very similar season. We're planning on roughly about the same time as we would have a build season end. That's when we want to slow down our meeting times. We still want to have, by 3 to 4 weeks in, we want to start getting our driver on that robot, getting him practiced. The unfortunate thing that we are seeing is blackout. You've already seen where 148 has said in public posts that this year's robot is their last reveal video. They'll probably never do another one. We're kind of in a similar boat where there's no longer the safety of the bag to stop people from just straight up stealing designs like they do in FTC. So you're going to have to keep stuff kind of close to the chest. So we're thinking that this was our last reveal video too, and some of the best practice that we get when we have other teams come and visit us and just practice with their practice robots, we don't think that those same teams are going to make the trip because they know that if they have a really cool idea, we can engineer it before our next competition, and then their advantage is gone.
Yeah, I think that's a concern going into the season next year, and I can't wait to talk about that on one of our shows. I'm sure there is a lot to talk about with that, and we could go for hours on that discussion. Unfortunately, we don't have the luxury to do that right now. So I'd like to ask you, James, what's the plan for the future? Tell us what's going on, plug your social media, let us know what's happening.
The next plans for us are driver training and driver practice. We've had the same driver for the 17, 18, and 19 robot, and he has graduated this year. So we're going to be utilizing our off-season events in Florida and potentially doing one out of state to train new drivers on both this robot and that second robot that we're going to be trying new things out on. For updates on what we're going to be up to throughout the summer, you can see us on Instagram at Team179, on Twitter at FRC179Swamp, and on Facebook at The Children of the Swamp.
Well, James, thanks for being on the show and giving us all this inside scoop on 179. It's been fun. Hope to see you in the future.
Thank you for having me. I look forward to being back on one of those fun little talk shows.
Alright guys, finally, we'll see you next week on The Warp Show Episode 2, and we'll see you in 2 weeks with the next episode of TAPS.